Okay, welcome back to exponent rules. So on page 5758 in your notebook, we're going to talk today about the multiplying rule and power of a power rule, which is kind of weird because they're like split up. Anyways, let's cut along these lines. We don't need to add anything to our table of contents. We already have these pages in there, and we don't have any new words worth knowing, so we don't have to worry about that either. Just going straight to our notes, which is nice. Okay, like I said, we're going to talk about the multiply rule and then power of a power rule. So first one, multiply rule, in regards to exponents. So remember, we're talking about exponents and powers, or numbers with little baby numbers in the corner. If we are multiplying by the same base number, so when multiplying by the same base number, we will add exponents. Okay, which again, I'm going to kind of show you why that works the way that it does. So for example, what this would look like is if I had, let's say, 2 to the third times, because we're multiplying, 2 to the 7th. Since they have the same base number, they're both 2's, then I can add the exponents. I can add these powers. So I write the base 2. I have 3 plus 7, so it would really be 2 to the 10th, which 2 to the 10th is rather large, so like you don't have to do all that. That's kind of a lot. We might also do it with letters, so out to the side right here, we might have something like x to the 7th times x to the negative 3rd, which we're not really supposed to have negatives, but I think it'll work out okay in our favor here, because if we're multiplying numbers with the same base, which these base numbers are both x's, then we can just add the exponents. So we can do 7 plus negative 3, which is 4. So x to the 4th would be my answer. Now maybe it gets a little bit trickier when we add in different numbers. Like if I have something like 4 y to the 3rd times 4 y, or 4 squared, let's do 4 squared, y to the 9th, like that. It seems like it's more confusing, but it's really not, because all of these things are really just being multiplied here. Even though I put 4y to the 3rd, it's really 4 times y to the 3rd times 4 squared times y to the 9th. Numbers butted up right up against each other is really just times. And so then we just kind of group them together. The numbers here that have the same base are the 4's. So this 4 right here, and then this 4 squared. The other numbers that also have a similar base are the y's. So like this y to the 3rd, and then this y to the 9th. And so I really just do each of them separately. So as a reminder, we want to think of every number as having an exponent. So this 4 right here really does have an exponent of 1. So this 4 we're doing 1 plus 2, because it's 4 to the 2nd over here. For the y, we're doing 3 plus 9. And so our final answer would be 4 to the 3rd, which that we might want to do. We can look at what that is in a second. And then y to the 12th, because 3 plus 9 is 12. And so if we did do 4 to the 3rd, that would be 4 times 4, which is 16, times 4, which is 64. Yeah. So we could also write this as 64y squared as our final answer. Okay. One other example that I want to show you, just because multiplication is not hard, but it can get confusing when there's multiple things going on. Let's say, for instance, I have something like 2x to the 2nd y times 3 squared x to the fifth, y to the negative first. Getting a little crazier in our examples here. So again, when we're multiplying numbers with the same base, we can add exponents. Well, it looks like we're just multiplying two numbers here, but we're really not. We're multiplying like 6 numbers, because in between all of these little numbers and letters are really multiplication symbols. So you can just add them in. Okay. The 2 and 3 do not have the same base, so I can't really add those exponents. So that's just going to be 2 times 3 squared, which we could probably do right away, but that's okay. We'll wait. Then these x's, though, they have the same base, so we can do x to the 2 plus 5 power, because we add when we're multiplying. And then finally y, we can add those exponents as well, because we're multiplying. And again, we want to think that if a number doesn't have an exponent, then it's really just 1. So 1 plus negative 1. And so now when I simplify here again, this 3 squared is going to be 9, times 2 will be 18. Then we'll have x to the 7th, because the 2 plus 5. And then y was 1 plus negative 1, which is 0. And y to the 0 power, anything to the 0 power is just 1. And so we don't really need to write that y down, because 1 times this will just be that. So hopefully that makes that kind of clear. Next thing we need to talk about is power of a power rule. So we're going to skip division. We'll talk about division tomorrow. We're going to talk about power of a power rule. So the power of a power rule is when I have a power and I raise it again to another power. So if I have a number with a power raised to another power, then multiply the powers. Okay, which again might seem kind of strange, but hopefully will make sense in a second. What this looks like is if I have something like 3 squared to the 7th power, so I have a number with a power raised to another power, then what I do is I just multiply the powers, so 2 times 7, and so this would be 3 to the 14th power, which is huge. Okay, one other small example of that, or maybe 2 others. If I have something like x to the 5th to the 7th, we would do x to the 5th times 7th, which is x to the 35th. Yikes. And then one last one, if I had something like y to the 3rd to the negative 4th power, well, we're not allowed to have negatives, but let's use the power rule first, which means I'll have y to the 3 times negative 4th, which is y to the negative 12th. And so now I've multiplied it out because I had a power to a power, but I'm not allowed to have negative exponents, so I need to move this to the bottom to make it not negative, and so this would be 1 over y to the 12th as my final answer. Okay, so I'm actually going to leave us here, I think, because in class tomorrow I'd like to talk about why multiplying rules work the way that they work and why power rule works the way that that works, so that this video is not too long. See you tomorrow.